Welcome to Unique World Education. Today we are going to discuss some numerical questions from the chapters of grade 11 physics, motion in a straight line, units and measurement, and motion in a plane. Very important chapters for the board exam, for the school exam, and for the NEET and JEE. Today we are going to discuss, I have taken the questions from the previous year school exam papers and some NEET questions also. So you can see this, okay, let's start the question right now. So you can see one question that is asked in the Avaron High School, Dubai. And you know one thing, this is a NEET question also. And very important thing, this is a question from units and measurement. Let's see how to find the dimension of some quantity. So before that, let me give you some theory topics, guys. It is always a sure question from this portion, dimensional analysis. So you should understand some basic dimensional formulas, like everyone will be knowing about what is the dimension of mass, it is m, and dimension of length is L, dimension of t, it is t. And some cases, if you are asked to find some quantities which is related to the current, you can use the dimension as A. If it is temperature, you can take the K. So these are some basic dimensional you should understand, you should know before doing any question from the units and measurement. And this is a sure question. So at least you will get a question related to the universal gravitational constant, right? So let's see how to find the dimension of a universal gravitational constant. So we know that F equal to G m1 m2 by r square. What is this? This is the force between, the gravitational force between two objects of mass m1 and m2, which is situated with a distance of r. So you have studied in grade 9, and from this one we need to find the dimension of this acceleration, this gravitational constant g. So how to take this g from this one? G equal to f r square by, take this r square into the left side, m1 into m2. I hope it is clear, right? And before that, just have a discussion about some basic quantities. See, velocity equal to distance by time. Everyone know this dimension, distance is L by t. What is the answer? Lt raised to minus 1. Acceleration, velocity by time, what is that? Again Lt raised to minus 1 by t. What is the answer? Lt raised to minus 2. Then what is the dimension of force? Force equal to mass into acceleration. So m Lt raised to minus 2. Then some basic quantities you should understand. Okay, distance r equal to L. These all things are the basic dimension you should understand before doing any question from the units and measurement. So let's substitute all the dimensions in this equation. So what is F? mLt raised to minus 2. What is r square? It is L square by, what is m1 m2? M into m. So you can just cancel 1 m from the numerator and the denominator, so that m will go into the numerator. It become m raised to minus 1, L cube, t raised to minus 2, t raised to minus 2, m raised to minus 1. So we can select the option as A. It is very simple, very important question, very repeated question. And I'm giving you some other dimensional formulas also. What will be the dimension of energy, for example? So guys, again I'm telling you, a sure question will be there always. You have to create an equation using dimensional analysis. That's a sure question. So in that you need to know how most of the questions will have some dimension you need to find for the energy. So energy equal to work done. Okay, you can use the equation for energy, or you can find the dimension of energy by using the equation work done. What is that? Force into displacement, right? So you can write like mLt raised to minus 2 multiplied with the L, you will get the answer mL square t raised to minus 2. This is the dimension of energy. Alright, so this is the dimension of energy. It's not asked here, so we got the first answer, universal gravitational constant m raised to minus 1, L cube. I hope it is very clear. L square is here, L is here, L cube is the answer, t raised to minus 2. This is the final answer. Let's move on to the next question. See this one. Which of the following physical quantities has the dimension ml square t raised to minus 3? So let's find out all the dimension first. So what is the dimension of work? Take it. Work equal to force into displacement, right? What is force? ml t raised to minus 2. Mass into acceleration. multiplied with distance is L. What is the answer? ml square t raised to minus 2. It's not the option. Let's go to pressure. So let's go to pressure. What is the dimension of pressure? Pressure equal to force by area. What is force? ml t raised to minus 2 by what is area? L square. What is the answer? Then you cut 1 L from this. ml raised to minus 1, t raised to minus 2. It is also not the answer. Now come to the last one, momentum. What is momentum? Mass into velocity. Actually, what is momentum? Momentum is an impact of an object which is having mass, which is hitting with the velocity v, right? If someone is hitting with an object with the mass with the velocity v, I'm getting a pain in my body, right? So that pain is the impact of this object, right? That impact is called momentum. So to get an impact, you have to hit me in my head with high speed, with a high mass object. So two physical quantities are directly depending on momentum, mass into velocity. So we can write directly as ml t raised to minus 1. So these three are not the option. We can find the dimension for power. What is the dimension of power? Power equal to work by time. So what is the dimension of work? ml square t raised to minus 2 by t. So you will get ml square minus 2 t raised to minus 2 minus 1, you will get ml square t raised to minus 3. I hope it is clear. The answer is power. We got the second option. Any doubt in this? Please comment in the chat box, guys. Any doubt in any of the question, you can just comment me in the chat box. I will just I will reply you in the comment, or else I will add that questions in the next video. All right. So let's move on to the next question. Yes, so it is again the question from the dimensions. So first of all, I'm trying to give you some basic idea about the dimensions from the chapter units and measurement. And this is a question asked from the school Avaron High School, Dubai. I forgot to mention the school name. It is Avaron High School, Dubai. Let's see. What is the dimension of A by B in the relation where F is the force, X is the distance, and T is the time? Let's see. F equal to A root X. In place of root X, I'm writing X raised to 1 by 2, right? Plus B into T square. Is it clear, everyone? So I just wrote the equation. I just substituted root X as X raised to 1 by 2. And X is the distance, T is the time. Everything is given. Oh, it is very simple actually. So we can use, all right, we need to find the A by B. So first thing, we need to find A, we need to find B. All right, okay, let it be there. Okay, let me change some colors. All right, so I think I can take, okay, this is better, I feel like. So let's write ml t raised to minus 2 equal, okay, before that, you need to study about what is the homogeneity principle of dimensional analysis. If there is an equation A equal to B plus C, you can write the dimension of A will be equal to dimension of B will be equal to dimension of C. This is the homogeneity principle. So all the equation, whatever equation, for example, V equal to U plus AT, S equal to UT plus half AT square, whatever equation it is, you can just verify that equation whether it is correct or not using this dimensional analysis. It's some other topic. I have added one question based on that topic also. Here we can just, using that property, I can take F equal to AX raised to 1 by 2. Clear? What is F? ml t raised to minus 2. A is a constant actually, so we can take the A, let it be, and X is the distance, so I can write it as L raised to 1 by 2. Is this clear? And I can take A equal to ml t raised to minus 2, take the L raised to 1 by 2 into the left side, you will get the answer like this, right? So then, so L raised to 1 here, 1 minus 1 by 2, it is 1 by 2, t raised to minus 2, we got the equation A, let it be A. Okay, so okay, it is, one second guys, so this is the final answer. This is not the final answer. We got the A from here. All right. Now we need to find B. How? Yes, use the same thing here. We can take like F equal to, one second guys, F equal to, okay, I will change the color at this time. Yes. F equal to B into, what is t square, right? T is the time it is given in the question. So we can write like ml t raised to minus 2. It is very simple. So b into t square, right? B into t square. So we will get b equal to ml t raised to minus 2 by t square. Correct? ml t raised to minus 2 by t square. So we will get it as ml t raised to minus 2 minus 4, equation number 2. Now we need to find a by b. So okay, so this is equation okay, that is one second guys. Yes, okay, so this is ml t raised to minus 4. You will get the answer for b as ml t raised to minus 4. Okay, so we got ml raised to 1 by 2, t raised to minus 2. Just find a by b. How you can find a by b? See, a by b you need to find, just write the dimension of a. What is the dimension of a? ml raised to 1 by 2, t raised to minus 2 by, what is the dimension of b? ml t raised to minus 4. Just solve it, m will be cancelled, right? So first option is not the answer. So we have b, c, d. Let's solve l raised to 1 by 2 minus 1. So it will come like 1 by 2 minus 1. T raised to minus 2 minus 4. You will get the answer l raised to minus 1 by 2. T raised to minus 2 plus 4. It will come plus 2. Which is our option? L raised to minus 1 by 2. L raised to one second guys. L raised to minus 1 by 2. Second, yes. L raised to minus 1 by 2. T raised to 2. Right. So here, okay, do it. So what is the option? L raised to minus 1 by 2, t raised to 2. Option B is our answer. I hope it is very clear. Once again guys, listen. So we done the questions like one second. Okay, so okay, so I'm just clearing on the left side, right side, and okay. So first we got the A as the answer. We got the A. We got it as A equal to m l raised to 1 by 2, t raised to minus 2. B as m l t raised to minus 4. We divided it. M got cancel. L 1 by 2 minus 1 minus 1 by 2. T become 2. This is how we got the answer. So option C. Let's move on to the next question. Oh yes, here is another application of dimension analysis. We need to consistency. We need to verify an equation, or we need to check the consistency of a given equation. So what is given here? V equal to pressure by density, right? So velocity equal to pressure by density all raised to 1 by 2. So first of all, we need to understand what is the dimension of a pressure. So what is pressure actually? It's same as like force by area, right? What is pressure? Force by area, pressure, stress, whatever it is, force by area. What is the dimension? It is clear. ml t raised to minus 2 by area, L square. So you will get the answer ml raised to minus 1, t raised to minus 2. And what is density? Mass by volume. So m by what is volume? Area into again a height. So you will get L cube. So you will get the answer ml raised to minus 3. Correct? Now let's see here. I'm just dividing pressure by density. You will get the answer. What is pressure here? ml raised to minus 1, t raised to minus 2 divided by ml raised to minus 3. First of all, let's divide this. We will get the answer. Okay, l raised to minus 1 minus 3, t raised to minus 2. So you will get the answer l raised to minus 1 plus 3, t raised to minus 2. You will get the answer l square t raised to minus 2. Now we need to take this square root, actually all raised to 1 by 2. So you will get the answer. What is the square root of L square? L. T raised to minus 2, it become t raised to minus 1. What is this? Actually it is dimension of velocity. Clear? This is what they are asked to find. So the dimension of V is LT raised to minus 1, and we proved on the RHS as also LT raised to minus 1. This is how we can verify an equation. To verify an equation also we need to know the dimensional analysis, dimensions of different functions. Okay. This is another type of questions which can be asked from this chapter, creating an equation using dimensional analysis. Once again guys, okay. Yes, creating an equation using dimensional analysis. Okay, let's see this one. A gas bubble, listen, a gas bubble formed from an explosion underwater oscillates with a time period t. Okay, with a time period t. Okay, with a time period t proportional to p raised to a, d raised to b, e raised to c, where p is pressure. Let's note it. P is pressure. You guys also write it with me. P is the pressure, d is density, e is energy. We need to find the values of A, B, C. It is very simple actually. Let's listen everyone. So first step, write the dimension of each quantities. Let's change the color. Alright. So first write the dimension of each quantities. I already given you what is the dimension of pressure. Force by area. What is the dimension of pressure? It is force by area. We will get the answer ml raised to force is ml t raised to minus 2 by L square. It is ml raised to minus 1 t raised to minus 2. We got it right. Now let's see. One second guys. Okay, now let's see what is the dimension of density. I already gave you what is the dimension of density. Mass by volume. It is mass by volume, m by L cube, ml raised to minus 3. Clear? Ml raised to minus 3. Now we need to find the density. We need to find the dimension of energy. What is the dimension of energy? We know that force into displacement, ml t raised to minus 2 into L equal to ml square t raised to minus 2. Now let's substitute everything here. T proportional to what is the pressure? ml raised to minus 1 t raised to minus 2. Okay, and density ml raised to minus 3 and energy ml square t raised to minus 2. Okay, so ml square t raised to minus 2. Just substitute A, B, C. Just open the bracket. T proportional to, I will get m here, here. So I can write it as A plus B plus C. I am directly writing it because there is a lot of steps are coming. Clear everyone? Now, okay, come to the L. So listen everyone, come to the L. I will mark it here. L raised to minus 1, L raised to minus 3, L raised to 2. So just add the powers. L raised to minus A minus 3B plus 2C. I hope it is clear. Got it? So what I did, I just multiplied all the L terms together. So I just added the powers. Minus A minus 3B plus 2Z and T raised to, what is here? Minus 2A, then minus 2A, then here there is no T and T is here itself. So we can find this is T, this is also T. So what you will get? Minus 2A minus 2C. This is the final equation you are getting. And on the left side, we didn't write that. On the left side, we can write m raised to 0, L raised to 0, T raised to 1, because there is no m, L terms. There is only T term is there because oscillates with a time period T. So time period T means it is the dimension T itself. It doesn't have any dimension with the m and L. So just let's compare the powers of everything. So you will get A plus B plus C equal to 0. I hope that is clear, right? And what is the second equation? L minus A minus 3B plus 2C equal to 0. Clear? Then minus 2A minus 2C equal to 1. Clear everyone? So this is equation number 1, equation number 2, equation number 3. Okay, so let's take the equation number 3. Some mathematical things are coming here. Let's take the equation number 3. Try to solve this everyone. I can take minus 2 outside, it become a plus c equal to 1 from the 3. Okay, from the 3 minus 2 into a plus c equal to 1. So a plus c equal to minus 1 by 2. Clear? We will get a plus c equal to, it is minus 1 by 2. So we can just substitute a plus c equal to minus 1 by 2 in the first equation. One second guys. Okay, so it is a plus c equal to minus 1 by 2. Take the equation 1, substitute a plus c equal to minus 1 by 2. So you will get b minus, so it's clear, right? A plus c in the place of, one second, in the place of a, in the place of a plus c, I just substituted minus 1 by 2. So b minus 1 by 2 equal to 0, and you will get b equal to plus 1 by 2. This is clear? You will get b equal to plus 1 by 2. So you can just substitute that b. Okay, so now we got this b equal to plus 1 by 2. And here we can do another method here. You see the equation number 1. Wait. You see the equation number 1. Okay. And equation number 2. You just add the two equation. You will get the answer like, see here. A plus minus a 0. B minus 3b minus 2b. C plus 2c 3c equal to 0 plus 3 minus 2b plus 3c equal to 0. So you will get 3c equal to 2b. And what is c from here? 2 by, what is c from here? It is 2 by 3 into b, and substitute the b here. You will get the answer. I'm just taking him. Okay, you be there. Okay, so just substitute the b here. 2 by 3 into 1 by 2, you will get 1 by 3. So you will get the BC as 1 by 3, B as 1 by 2. So now I am not doing the next step. You just substitute, you will get A equal to minus 5 by 6. I hope it is clear. A you will get it as minus 5 by 6. I done the explanation for finding B and finding C. So you need to find the A equal to minus 5 by 6. Do the calculation, you will get the answer. Now I am just clearing some steps here. Before that, you can take the screenshot. Everyone take the screenshot. Now I am just clearing this portion here. Okay, now nothing, we have to only substitute. Actually we found the values A, B, C. What is the answers? A equal to minus 5 by 6, B equal to 1 by 2, C equal to 1 by 3. This is the final answer. They are asked to find A, B, C. But you can also just substitute here T equal to, just remove the proportionality. You can substitute at K into P raised to minus 5 by 6, D raised to B, right, 1 by 2, E raised to 1 by 3. This is the proper way of finding the answers. Okay, so let's do more questions on coming. Okay. Alright, so the video is going too lengthy, so let's conclude the video right now. Now let's move on to the next videos after this one. Okay, next questions after this one.